Okay, so this set of notes is specifically looking at permutations. Now, we'll point out why they're permutations, but all of the examples in this set of notes are permutations examples. So again, the biggest thing is to recognize why it's permutation and then how to set it up and then type it in the calculator. Alright, so the first example, we have a group of 30 students. Alright, that's N, right? 30 students. How many ways, so we're counting, can a president, vice president, and treasurer be chosen? So this is a lot like the first example I did, right? Since there's a rank, right? Position 1 was president. Position 2, vice president. Position 3, treasurer. It's different which position you're picked for, which order you're picked in. And so order matters. Alright, that's what makes it a permutation. And again, I have to pick 3 different people. If I pick the same person twice, I don't get 3 different people. Right, so it is a permutation. N is 30, R is 3. Right, I'm picking 3 people because there are 3 positions out of 30. So it's 30, permutation, choose 3. And again, permutations typically are big numbers. So 2, 4, 3, 6, 0. That's how many different ways they can pick 3 people out of 30 to fill the positions of president, vice president, and treasurer. Next example. How many different ways can gold, silver, and bronze medal be awarded if there were 8 runners? So again, we're assuming this is random. If we're just trying to figure out how many different ways the 8 runners could land in gold. Remember, gold would be first, the silver would be second, bronze would be third, and it matters, right? A bronze medal is different than a gold medal. Right? Order is important, so this is a permutation. We started with 8 people, and we're going to hand out 3 awards. So we're choosing 3 out of 8. So it's a permutation, 8, choose 3. So there are 336 different ways 8 people could land in gold, silver, and bronze. Again, if we're just doing this randomly, suppose they all run in very similar times, all right? And so, well, what's the randomness if it was randomly done? Well, there are 336 different ways to do that. All right, suppose for a radio segment, a DJ can play 7 records, so 7 songs. If there are 13 records, 13 songs to choose from, how many ways can the program for this segment be arranged? So that's the important word, range, right? That means lineup, right? You're lining up the songs. And we want to know how many different lineups they are, so that means order. Order is important because first song, second song, third song, fourth song, fifth song, right? We were figuring out the arrangement. There might be a better arrangement, a better order for the songs to flow than a different order, right? So again, order matters. It's different for the flow. Alright, so we had 13 to choose from, and we're picking 7. Alright, so it's a permutation, 13, choose 7. And so there's quite a few ways to do this. 8, 6, 4, 8, 6, 4, 0. There are over 8 million ways to order 7 songs if we're choosing from a group of 13 songs. Alright, so this one I've got a few questions for. Alright, so suppose we have 7 performers, and I'm just going to generically label them as performer A, performer B, performer C, D, E, F, and G. Alright, so we've got 7 people. So N is 7. Alright, to appear in a fundraiser, the order of importance is determined by random selection. We're going to be finding probabilities this time. Right? Remember, probabilities is the number in my event divided by the number in my total outcomes. Alright, so we're ordering our performers, which means we're going to take all 7 and select them in different orders, right? Some people might prefer to be earlier in the program. Some people might prefer to be later in the program, right? The lineup matters, right? Whether you're the first person, that's a different alignment than the second person, right? It actually uses the word order. When it uses the word order, order is important. And so the first thing I'm going to do before I get to these are the events. I'm going to find my total. I'm going to find my total outcomes first. So what are the total number of ways to order the performers? Right? That would be the big set. Well, I'm picking 7, and I'm ordering them in 7 spots. So I'm going to choose all 7. So this is one where I'm choosing the whole group. And so technically it is 7, permutation, choose 7. Another way you could write this is the very first one that I talked about. When we're picking everybody, that's the factorial case. And it doesn't matter. You can use permutation 7, choose 7. It's exactly the same as 7 factorial, because what both of those give you is there were 7 for the first position, 6 for the second, 5, 4, 3, 2, until we get down to the last person is the last position filled. All right, so it's that order of numbers where we subtract them every time. All right, so this comes out to be 5,040 total ways we can order 7 people. All right, so that's the big group. That's the one we're going to divide by, right? That's the total number of outcomes. All right, so the first one we're looking for is the event that the comic, all right, so the performer E will be first, all right? So that's the event that performer E is first. So how many ways out of my 5,040 is the performance E first? All right, so that's what we always start off with what we're given. When we're given, well, we pick E. He's in the first spot, which means there are still, so he's been picked. All right, so I've picked E. He's gone. He's been picked. He's been put in position 1. All right, that means there are still, once I've picked E and he's first, 6 performers left to fill out 6 places. And so basically we've eliminated one of the performers, right? We've picked one of them, we've placed one of them, and so we have the remaining spots left. And so what this comes out to be is I've got 6 people left to fill out the remaining. So this would be 6, 5, 4, 3, 2, 1. So this would be 6 factorial, or if you prefer, you had 6 people left to fill out the 6 remaining positions left. You could use the permutations formula too. 6, choose 6. All right, which comes out to be 720 ways. So out of, so it's the probability, right? That's not the answer. The probability was my event over my total. The event was there are 720 groups where E is first, performer E is first, out of the total 5,040. So that's the probability, right, which actually reduces down to 1/7. All right, so there is 1/7, or you can find the decimal, and I'll leave you guys to do the decimal since we've done those in the last examples. All right, so that's the probability for the first event. And the probability that performer E is first is 1 out of 7 chance. All right, the next one. Comic C will perform 5th, and comic B will perform last. So again, this is my event. So we're going to figure out the event first. So first thing we have to do, I'm going to write my 7 spots out. 1, 2, 3, 4, 5, 6, 7. C is 5th. So 1, 2, 3, 4, 5. So C is here. B is last. So we've already put C and B in order. So we've already picked C and B, which means I have 5 spots left to fill with the 5 performers left. So again, I've eliminated 2 spots in my lineup, which means I've eliminated 2 people. So I have 5 people left to fill out those 5 spots. So again, this is selected, so the open spots are left. So I'm filling this out. I'm going to write my numbers down in a different color. So in the first spot, there's 5 people, then there's 4, then there's 3, then there's 2, and then the remaining guy goes between C and B. All right. And so this means I've got 5 people to fill out 5 spots. And so this would be 5 factorial or 5 permutation, choose 5, which comes out the same. 5 factorial or 5 permutation, choose 5 means there's 120 different ways. I could pick C in position 5 and B in the last position. Alright, so that's not the answer though. Remember, this is the probability is my event over my total, which would be my 120 ways I can do that out of my 5040, which simplifies to 1 over 42. Alright, there's a 1 over 42 shot that will be the outcome. Alright, the last one. How many different the comedians will perform in the pot? So we've already set it up. We're going to put it in alphabetical order. A's first, B's second, C's third, D's fifth, E's sixth, and F is 7. This is one order, one outcome. So in this case, what's the probability that we get, if we were randomly do it, what's the chance that it's in alphabetical order? Well, there's one shot out of the total. That's the one of my 5040 outcomes. So 1 out of that. So again, this would be that, or if you do the 7 factorial. And then you can find the decimal and the percent. I'll leave that for you to do. That's just typing it out on your calculator. Alright, next example. There are 8 Republicans and 12 Democrats. To form a group, we're going to pick from 8 Republicans and 12 Democrats to form a group with a president, a vice president, and treasurer. Alright, so again, since there's a rank, order matters, so this is a permutation. We had a total of 8 plus 12, so 20 people total. And we're going to pick 3, right? We have a president, a vice president, and a treasurer. I couldn't think of how to say it. All right. And we're going to find probabilities. So these are all probabilities. So the first thing I'm actually going to find before I get started in finding my probabilities is, right, we're going to be finding probabilities. So remember, probability is my event over my total. So I'm going to figure out my totals. All right, how many possible ways are there going to be? So I'm going to find the totals first. The total number of possible outcomes. Well, that would be if I take 3 out of all of the people, so 3 out of 20. So this would be a permutation. 20, choose 3. All right, so you could actually do this multiplication too. 20 for the president, 19 for the vice president, 18 for the treasurer, should give you the same answer, which is 6,840 different outcomes total. So that's my total. Alright, so I need that when I go to do my probability, and I divide by that number. Alright, out of all of the groups, how many ways are there to... Alright, so for part A, find the probability that all of the offices will be held by Republicans. So what's the way where we get all 3 positions filled by Republicans? And so that's my event. So I'm going to figure out my event and then divide by my total. All right, the event is we only pick Republicans, which means I'm only selecting from the 8 Republicans. All right, N is only 8 because I'm only selecting from the Republicans. I'm still going to pick 3 because there's 3 positions to fill out. But my group that I'm selecting from is now only 8, right? Because I'm not picking out of everybody. I'm only picking the Republican group. And so this would be a permutation 8, choose 3 would be my event, which is 336. All right, so that's the event. So the probability, event over the total. You could fill out the permutations if you wanted to on your calculator. So if you use just the permutations formula, up top would be 8 permutations, choose 3, divided by 20 permutations, choose 3. Or you could type the numbers in. The event was 336 groups are held by Republicans out of my 6,840 total. Which, again, that reduced fraction is 14 out of 285. And I'm just going to leave the reduced fractions. Again, just make sure you're careful on the homework and the quizzes. If it says write the fraction, give the fraction. It says give the decimal, give the decimal. If it says percent, give the percent. And since I did all those in the last one, I'm going to assume you know how to do those at this point. Alright, same problem, but now we're going to look at a different case. Find the probability. So again, probability would be my event over my total. Right, number in my event over my total. This time, what's the chance that we get all of them held by Democrats? So there's my event. We're only pick from the Democrat group. So instead of selecting from everybody, I'm only selecting from the 12 Democrats. So N is 12. I'm still going to pick 3. But I'm picking 3 from the Democrats only. And so my event is 12 permutation, choose 3. Right, and if we write that out, that's 1,320 in my event. Alright, so the probability. Again, you can write it all in once if you wanted to. You can use the numbers or the permutation. So if you did the permutation, up top would be the 12 permutations to 3. There's my Democratic group. Over the total group, 20 permutations, choose 3. Or the numbers, that's 1320 over 6,840, right? There are, out of the total number of groups, the 6,840, 1,320 of them are groups with only Democrats in them. All right, so the odds are, if we write that as a reduced fraction, that's 11 out of 57. All right, next example. I believe this is the last example. Find the probability at least one of the offices will be held by a Republican. So probability, remember this is the at least case. We have a special way to do this. Which means one of the 3 is held by a Republican, or 2 of the 3 are held by Republicans, or all 3 are held by Republicans. The easiest way to do the at least one case is use the complement. 1 minus the probability that it's held by no Republicans, which means all Democrats. Which we just found that in the last example, right? 1 minus the chance that it is all Democrats, well, that was the 11 out of 57. So if I write that, that would be 46 out of 57 would be the reduced fraction. Again, I'll leave the decimal and the percent to you. Just make sure you're careful when you read. They ask for a percent, give it as a percent. They ask for a fraction, give it as a reduced fraction. If they ask for a decimal, make sure you round 2 places, 3 places, however many places they ask for it. Just make sure you're careful with those. But there's the probability. Alright, so that finishes up the going through permutations examples. The next one is we're going to go through combinations examples. Alright, so my next set of notes is all combinations.